Hi, we're looking at a shot, although unfortunately it was scrubbed today because of weather, but this is the Falcon rocket that's going to take these two American astronauts into space. Very exciting because this is first time in about a decade where we've had Americans being launched in an American spacecraft on American soil. We've had to be going to Russia, I think Kazakhstan really, to hitch rides on the Russian spacecraft, which is very capable spacecraft, but it's nice to see that American astronauts are going to be going back to space on American spacecraft. But it was scrubbed. However, this is a good time to talk about our next unit. Our next unit is going to be on what are called fundamental forces. And there's two that we're going to focus on. We might hit on a third one, but the two that we're going to focus on are gravity and the electric force. Now, you're very familiar with gravity. You're a little bit less familiar with the electric force, although they're both all around you all the time, and they're both super important to the structure of nature. All right, but let's talk about energy real quick, because as we're wrapping up on energy. When these astronauts get going up into space, they're going to be going 17,000 miles an hour, and they're going to be several hundred miles above the Earth's surface. What kind of energy do we call, what kind of energy is associated with motion? Yes, kinetic energy. What kind of energy is associated with being up high? Gravitational potential energy. So it turns out they're going to have a lot of kinetic energy and a whole lot of gravitational potential energy. Where's it going to come from? It just doesn't spontaneously come into existence. Can you tell me? Yes, the rocket. So inside this rocket, there is a tremendous amount of chemical potential energy stored up, and that's going to be transformed into kinetic energy and gravitational potential energy, at least on launch day, not today. All right, so let's talk about gravity. You say, well, gravity is just gravity. We already know how to calculate gravity. Mass times 10 newtons per kilogram. You learned that in Physics A. What else is there to know? Well, what happens to the force of gravity when you start getting further and further away from the Earth? Like where the space station is and where this rocket will be taking these astronauts on Saturday, hopefully. Does it stay the same? Does it disappear? Does it get stronger? Does it get weaker? Well, these are things that we're going to want to explore. So your first assignment is a gizmo on not electric force, gravity force. Okay, we're going to do a couple of assignments on that, maybe a little bit of work on orbital motion before we move on to the electric force. Okay, so if you're not doing anything on Saturday, check out the launch, okay? It's really exciting. And look at those cool space suits. Really cool. All right, we'll see you soon.